We're looking at the back of Stoichiometry Worksheet 1, and if you're looking at the back, the only difference you're going to notice here is that there are no products listed. So you need to decide what type of reaction am I looking at and what are the products going to be. So in these three situations, really quickly, I have carbon-hydrogen reacting with an oxygen, which tells me this is a combustion reaction, so I know they're going to produce carbon dioxide and water. Okay. And then here we have a decomposition reaction. So we only have one thing on the reactant side, so it's going to break apart into its elements. So aluminum plus oxygen, and I have to put a 2 here because oxygen is one of the diatomics, so if it's left on its own, it's going to have a 2. And then lastly, this one at the bottom, we have 2 separate compounds, and so this is a double replacement. And so they're just going to switch partners. So sodium is going to end up with nitrate, and they have the same charge, so no additional numbers need to be put there. It's a +1 and -1. And then here, iron, which has a +3, and we know that because there's 3 here that it gave to nitrate earlier. So that 3 actually belongs to the iron, and it's getting with carbonate, and carbonate is a plus. Well, not a plus, it's a -2, because it gave that 2 to sodium. So carbonate's going to give that 2 to iron, and iron's going to give carbonate that 3. So that's how you predict what the product is. Now you have to go back and do the second step, which is balancing these equations. So I'm only going to do one for you, and we'll start at the top. This is probably the trickiest one because you have to remember the rules of combustion. In the rules of combustion, you have to balance the carbon. You can't see that on the video, so here. Carbon, then the hydrogen, and then the oxygen. And combustion can always be tricky, so we are going to do this very carefully. So I have 4 carbons here, but I only have 1 here, so I'm going to need 4 over here. But since things can change in this sort of reaction, I'm just going to put this 4 up here. If we go to our hydrogens next, I have 10 hydrogens, but I only have 2 here, so I'm going to put a 5 up here. So 5 times 2 is 10. Lastly, if we look at our oxygens, I only have 2 in my reactants, but in my products I have 8 plus 5, which gives me an odd number. So that's 13, and that's what I was afraid of. The only way to get to 13 is to multiply this by 6.5. Now, if you remember the rules of combustion, you can't have, well, they're the rules of balancing. You can't have any non-whole numbers. So if this is 6.5, we need to turn it into a whole number. And how we do that is we multiply every number by 2. So this, which is a 1, is going to become 2. This is going to become a 13. This is going to become an 8. And this will become 10. Okay. Now that we have it balanced, we can write the mole ratios. So first I'm going to compare my reactants to my reactants. So I have 2 moles of C4H10 or to my 13 moles of oxygen. And I'm going to compare my reactant to my product. So I have 2 moles tetracarbon decahydride to 8 moles of carbon dioxide. Okay. And then I lastly have to compare my reactant to my last product, which is 2 moles of C4H10 to 10 moles dihydrogen monoxide. Next, we have to compare our other reactant to the products. And let me go back and put my little arrows here. These are just reminders. So I have 13 moles of oxygen compared to 8 moles of carbon dioxide. I have 13 moles of oxygen compared to 10 moles of H2O. And then I'll go back and put my arrows. And then lastly, I have to compare my products to my products. So I have 8 moles of carbon dioxide to my 10 moles of H2O. And then that's it.